I'll be discussing how OASIS standards and projects enable cybersecurity automation. This is a poster OASIS made for the recent Black Hat. I don't expect you to be able to read this. I'll zoom in on parts of it to explain cybersecurity automation. I'm going to describe how OASIS vendor-agnostic standards make interoperable cybersecurity a reality. I'm going to start in the middle of the chart using a particular use case. You are operating software, and it has a vulnerability. A threat actor successfully attacks you, exploiting that vulnerability. Fortunately, there are indicators of compromise. You can look for those indicators with Kestrel, an open cybersecurity alliance open source tool for threat hunting, for sharing how to hunt, for sharing what to look for, and what you found. Maybe you started hunting because your ISAC shared threat intelligence using the OASIS standard sticks transmitted over taxi. Maybe your security vendors weren't standard yet, and you used Stick Shifter, an OCA open source tool to convert your vendor's proprietary format into the standard sticks format. And maybe you gain knowledge about your attacker using the threat actor context, or TAC ontology, also shared from your ISAC over sticks. So now you know a whole lot, but you still haven't done anything yet. What should you do? What to do is called a course of action, or more commonly known as playbooks. Cacao is an OASIS standard for how to document your playbook, so it can be run by SOAR tools, shared within your org, or shared with other organizations. Playbooks are the core of cybersecurity automation. Now, what's in these playbooks? Control logic and commands. What sort of commands? Commands to control your firewalls, your intrusion detection devices, and even to kick off the threat hunting I mentioned. Commands to your honeypots, commands to your sandboxes, and of course, commands to all your endpoint security. But what about the fact there's multiple vendors with a Tower of Babel of different commands to do the same thing? Well, that is where OpenC2 comes in. Open Command and Control is a vendor-agnostic OASIS standard on controlling security. Now, everything we've talked about so far has been reactive. Let's go to the top of the original diagram for another big picture view. Now, we started with software that has a vulnerability. It actually starts sooner with the creation of that software by a software developer who hopefully is also creating an SBOM, or software bill of materials, when they create that software. Hopefully, they're also doing static analysis and recording their results using Sarif, another OASIS standard. And as the vulnerabilities are found, hopefully they're also issuing VEX, or vulnerability exploitability, as well, using the Open Security Advisory Framework, or CSAF standard. Now, how do you use this info? You use it with PACE, which I'm going to cover in a minute. But first, let me talk about one more acronym. VSMI is for Value Stream Mapping Interoperability. Value Stream Mapping is optimizing this whole chart based on the value to the organization. VSMI is a standard, it's still in development, to allow VSM to collect and disseminate the data it needs to either receive or to distribute to determine that value stream mapping, to determine the value. VSM helps with the business justification to do all the things on this chart and to only do it to the extent optimized for the business. So now let's get back to the crown jewel of all this work, PACE. One OASIS open project is called Open Cybersecurity Alliance, whose mission is vendor-agnostic, open-source, standards-based cybersecurity. Kestrel and Stick Shifter that I mentioned earlier are both OCA subprojects. Another OCA subproject is PACE, Posture Attribute Collection and Evaluation. Posture is security posture, and posture attributes are all those things that contribute to your security posture. You need to collect these attributes, i.e. you need the data about your security, and you need to evaluate your posture, i.e. you need to assess what a given attribute value means with respect to increasing or decreasing your risk. SBOMs are a type of security posture attribute. So are its correlation with the National Vulnerability Database. So are VEXs. So are the outputs of Kestrel, i.e. whether or not hackers are currently in your system. Basically, any data associated with security controls or with threat intelligence are posture attributes. Here's an eye chart on the PACE architecture, which I'll expand. The PACE architecture is pretty simple. Outside of PACE, you have something that wants to know what your security posture, so it can make a decision. For example, a SOAR system. Also outside of PACE are all these assets you desire to know the security posture of. Inside of PACE are three simple components. Posture collection gets the attributes from outside and brings them into PACE. The posture attribute repository stores those attributes, and posture evaluation is for evaluating what those attributes mean with respect to your security posture. So SBOM management systems are a type of PACE system. They get SBOMs, they get data from the NVD, they get CVEs, they get VEXs, etc., and they evaluate, put it all together, what it means to your security posture. Now you can have multiple PACE systems interworking. Shown here is a very complex 14 PACE ecosystem. There's 5 collection systems, 4 repositories, 3 evaluation services, and 2 integrated PACE systems, all operating over standard interfaces. Now I'll caveat these standards are still being developed. PACE is a very new concept, but there are already vendors in this space. I think I've explained all the icons in this poster and how they work together in a cybersecurity automation ecosystem.